In this video, I'm going to explain restrictions in assignment problem maximization case. Please check my previous video for restrictions in assignment problem unbalanced assignment case. Here, first we have to assign a high cost infinity in the restriction cell and then proceed the problem in the usual manner. Now let us move on to the problem. An airline company has drawn up a new flight schedule involving 5 flights to assist in allocating 5 pilots to the flights. It has asked them to state their preference score by giving each flight a number out of 10. The higher the number, the greater is the preference. Certain of these flights unsuitable to some pilots owing to domestic reasons. What should be the allocation of the pilots to the flights in order to meet as many preferences as possible? Here, 5 pilots and 5 flights are given. Their preference score is also given here. Pilot A, the maximum preference is for flight 1. Pilot B, the maximum preference is for flight 1. And pilot C, the maximum preference is flight 3. And pilot D, the maximum preference is flight 4. And pilot E, the maximum preference is flight 3. Here, we have to find the optimum allocation of the pilots to the flights in order to meet as many preferences as possible. We have to find the maximum preference score for this particular problem. Here, pilot A is not suitable for flight 3 due to some conditions. Pilot C is not suitable for flight 5. Step 1. We have to assign a high cost in the restriction cell. Here, pilot A is not suitable with flight 3 and pilot C is not suitable with flight 5. So, we have to assign a high cost infinity in that cell. 8, 2, infinity, 5, 4, 10, 9, 2, 8, 4, 5, 4, 9, 6, infinity. 3, 6, 2, 8, 7, 5, 6, 10, 4, 3. Step 2. Convert the maximization problem into equivalent minimization problem by subtracting all the entries with the highest cost. In this problem, we have to calculate maximum preference score. For that, we have to convert the given problem into minimization problem. Assignment is possible only for minimization problem. So, we have to subtract all the entries with the highest cost 10. 10 minus 8, 2. 10 minus 2, 8. Infinity. 10 minus 5, 5. 10 minus 4, 6. 10 minus 10, 0. 10 minus 9, 1. 10 minus 2, 8. 10 minus 8, 2. 10 minus 4, 6. 10 minus 5, 5. 10 minus 4, 6. 10 minus 9, 1. 10 minus 6, 4. Infinity. 10 minus 3, 7. 10 minus 6, 4. 10 minus 2, 8. 10 minus 8, 2. 10 minus 7, 3. 10 minus 5, 5. 10 minus 6, 4. 10 minus 10, 0. 10 minus 4, 6. 10 minus 3, 7. Step 3. We have to check the balance condition. Here we have 5 pilots and 5 flights. Number of rows is equal to 5. Number of columns is equal to 5. Since number of rows is equal to number of columns, we can say that the problem is a balanced one. Step 4. Row reduction. Select the least element from each row and subtract it from all the elements in that row. We have to select the least element from each row. In the first row, minimum element is 2. In the second row, 0. Third row, the minimum element is 1. Fourth row, the minimum element is 2. Fifth row, the minimum element is 0. With the minimum element, we subtract all the elements. 2 minus 2, 0. 8 minus 2, 6. Infinity. 5 minus 2, 3. 6 minus 2, 4. Second row, 0 is the least number. So you write as it is 0, 1, 8, 2, 6. Third row, 1 is the least number. So 5 minus 1 is 4. 6 minus 1 is 5. 1 minus 1, 0. 4 minus 1 is 3. Infinity. Fourth row, 2 is the least number. 7 minus 2 is 5. 4 minus 2 is 2. 8 minus 2 is 6. 2 minus 2 is 0. 3 minus 2 is 1. Fifth row, 0 is the least number. So we write as it is 5, 4, 0, 6, 7. Step 5. Column reduction. Select the least element from each column and subtract it from all the element in that column. First we have to write the column minimum. First column, 0 is the least number. Second column, 1 is the least number. Third column, 0 is the least number. Fourth column, 0 is the least number. Fifth column, 1 is the least number. Now we have to subtract each column with the minimum number. In the first column, 0 is the least number. So we write as it is 0, 0, 4, 5, 5. In the second column, 1 is the least number. So 6 minus 1 is 5. 1 minus 1, 0. 5 minus 1 is 4. 2 minus 1 is 1. 4 minus 1 is 3. Third column, 0 is the least number. So write as it is infinity, 8, 0, 6, 0. Fourth column, 0 is the least number. Write as it is 3, 2, 3, 0, 6. Fifth column, 1 is the least number. So 4 minus 1 is 3. 6 minus 1 is 5. Infinity. 1 minus 1, 0. 7 minus 1 is 6. Step 6. To find the assignment. After performing row reduction and column reduction, we have to find the assignment. For finding the assignment, we have to go for row scanning first. In the row scanning, if you have single 0 in that row, you have to put a square mark on it. If you have more than one row, you skip that row. In the first row, you have a single 0. So put a square on it. Once you put a square, you have to draw a vertical line passing through that 0. In the second row, you have a single 0. So you put a square on it. If you have more than one row, you have to skip that row. Here we have a single 0. So we mark square and then we draw a vertical line passing through that 0. In the third row, we have single 0. So put a square on it. Once you put a square, you have to draw a vertical line passing through that 0. In the fourth row, we have 2 zeros. So you skip that row. In the fifth row, we have no zeros. Once you performing row scanning, you have to check all the zeros are covered with the lines or not. Here some zeros are not covered with the lines, so we have to go for column scanning. For column scanning, first three columns are cancelled. Fourth column, we have a single zero. So you put a square on it and then you draw a horizontal line passing through that zero. In the fifth column, no zero. Once you perform column scanning, you have to check all the zeros are covered with lines or not. Here all the zeros are covered with lines. Next we have to check number of rows is equal to number of assignments or not. Here number of rows is equal to 5. Number of assignments 1, 2, 3, 4. Number of rows not equal to number of assignments. So the current assignment is not optimal. To get the optimum assignment, we have to find a new cost matrix. For finding a new cost matrix, we have to use Hungarian algorithm. First step, we have to find the minimum value from the uncovered portion. Here the minimum element is 2. With this, you subtract all the uncovered portion and you have to add this with the intersecting elements and write the other element as it is. Let me repeat. If you have no lines, you have subtract. If you have a single line, write as it is. If you have a double line, you have to add that one. Then you will get a new cost matrix. The new costs are 0 is covered with a single line, write as it is. 0 is covered with single line. 4 is covered with a single line. And 5 is covered with a double line. So you have to add 5 plus 2 is equal to 7. 5 is covered with a single line, write as it is. Next 5 is covered with a single line, write as it is. 0 is covered with a single line, write as it is. 4 is covered with a single line, write as it is. 1 is covered with a double line. So 1 plus 2 is equal to 3. Now 3 is covered with a single line, write as it is. Infinity. 8 is covered with a single line, write as it is. 0 is covered with a single line. And 6 is covered with the 2 lines. 6 plus 2 is equal to 8. 0 is covered with a single line. Next 3 is uncovered. 3 minus 2 is equal to 1. 2 minus 2 is equal to 0. 3 minus 2 is equal to 1. 0 is covered with a single line. Write as it is. 6 is uncovered. 6 minus 2 is equal to 4. Next column. 3 is uncovered. 3 minus 2 is equal to 1. 5 minus 2 is equal to 3. Infinity. 0 is covered with a single line. Write as it is. 6 minus 2 is equal to 4. This is the new cost matrix. Then we have to find the assignment using Hungarian algorithm. For finding assignment, we have to go for row scanning first. In the first row, we have a single zero. So you put a square on it and then you have to draw a vertical line passing through that zero. In the second row, you have 2 zeros. So you skip that row. In the third row, you have a single zero. So you put a square on it and then you have to draw a vertical line passing through that 0. In the fourth row, you have 2 zeros. So you skip that row. In the fifth row, no zeros. After row scanning, you have to check all the zeros are covered with lines or not. Here some zeros are not covered with the lines. So we have to go for column scanning. In the column scanning, first column already cancelled. In the second column, we have a single 0. So you put a square on it and then you have to draw a horizontal line passing through that 0. Third column already cancelled. In the fourth column, we have a single 0. So you put a square on it and then you have to draw a horizontal line passing through that 0. Now all the zeros are covered with lines. After that, you have to check the number of rows is equal to number of assignment or not. Here number of rows is equal to 5. Number of assignments is equal to 4. Since the number of rows not equal to number of assignments, the current assignment is not optimal. To get the optimum assignment for this problem, we have to find a new cost matrix. For finding a new cost matrix, we have to follow some steps in Hungarian algorithm. First step, you have to select the minimum value from the uncovered portion. Add it with the intersecting values, subtract it with the uncovered elements and write the other element as it is. Then you will get a new cost matrix. Here the minimum element is 1. With this you have to subtract all the uncovered elements and you add it with the intersecting elements and write the other elements as it is. The new cost matrix is 0 is covered with a single line, write as it is. 0 is covered with a double line, so you have to add it with the minimum element, so 1. 4 is covered with a single line, write as it is. 7 is covered with a double line, so you have to add it with the minimum element. 7 plus 1 is 8. And 5 is covered with a single line, so you write as it is. Second column, 5 is uncovered, so you subtract with the minimum element, that is 4. 0 is covered with a single line, write as it is. 4 is uncovered, so 4 minus 1 is 3. 3 is covered with a single line, write as it is. 3 is uncovered, so 3 minus 1 is equal to 2. Third column, infinity. 8 is covered with the 2 lines, so 8 plus 1 is equal to 9. 0 is covered with a single line, write as it is. 8 is covered with the 2 lines, so 8 plus 1 is equal to 9. 0 is covered with a single line, so write as it is. Fourth column, 1 is uncovered, so 0. 0 is covered with a single line, 0. 1 is uncovered, so 1 minus 1 is 0. 0 is covered with a single line, so you write as it is. 4 is uncovered, so 4 minus 1 is equal to 3. Fifth column, 1 is uncovered, so 1 minus 1 is equal to 0. 3 is covered with a single line, so write as it is. Infinity. 0 is covered with a single line, so write as it is. 4 is uncovered, so 4 minus 1 is equal to 3. This is the new cost matrix. Now we have to find the assignment using Hungarian algorithm. For that, first we have to perform row scanning. In the first row, you have 3 zeros, so you skip that row. Second row, you have 2 zeros, skip that row. Third row, you have 2 zeros, so skip that row. Fourth row, you have 2 zeros, so you skip that row. Fifth row, you have a single 0, so you put a square on it and you have to draw a vertical line passing through that 0. After row scanning, you have to check all the zeros are covered with the lines or not. Here most of the zeros are not covered with the lines. So we have to go for column scanning. In the column scanning, you have to check the first column. In the first column, you have a single 0. So you have to put a square on it and then you have to draw horizontal line passing through that 0. In the second column, we have a single 0. So you put a square on it and then you have to draw a horizontal line Third column already cancelled. Fourth column you have 2 zeros. So you skip that column. Fourth column we have 2 zeros. Skip it. Fifth column you have a single zero. So you put a square on it and then you have to draw a horizontal line passing through that zero. We have a single zero in the third row. So you put a square on it and then you have to draw vertical line passing through that zero. After that, you have to check all the zeros are covered with the lines or not. Here all the zeros are covered with lines. Next, we have to check number of rows is equal to number of assignments or not. Here, number of rows is equal to 5. Number of assignments is equal to 1, 2, 3, 4, 5. 5 assignments. Here number of rows is equal to 5. Number of assignments is equal to 5. So the current assignment is optimal. Next step, we have to find the optimum assignment schedule of the pilots to the flights. Here pilot A assigned to flight 1. Pilot B assigned to flight 2. Pilot C assigned to flight 4. Pilot D assigned to flight 5. Pilot E assigned to flight 3. Pilot A to flight 1. Pilot B to flight 2. Pilot C to flight 4. Pilot D to flight 5. Pilot E to flight 3. Next, we have to find the maximum preference score for the pilots to the flights. This you have to taken from the original problem. Pilot A assigned to flight 1, so the score is 8. Pilot B assigned to flight 2, so the score is 9. Pilot C assigned to flight 4, so the score is 6. Pilot D assigned to flight 5, so the score is 7. Pilot E assigned to flight 3, so the score is 10. The score for pilot A is 8. The score for pilot B is 9. The score for pilot C is 6. The score for pilot D is 7. The score for pilot E is 10. If you add, you will get 40. The maximum preference score for the pilots to the flights is 40. In this way, you have to find the optimum allocation schedule and the maximum preference for this problem. Here, first we assign an infinity in the restriction case. After that, we have to convert the given problem into minimization problem, and then we apply Hungarian algorithm to get the optimum assignment. Hope you all understand. If you like this video, please share and subscribe. Thank you for watching.